Today the students and I worked very hard on having different examples of partial product, and I told them that they could choose any 3-digit number divided by a 1-digit and work on partial product. So my first example, I'm going to choose 295, and I want to divide that by 4. Now when I look at this, I ask them if they see any basic facts. Does 4 go into 200 evenly? It might, so we could choose, well, I know 4 times 5 gets me 20, so I know that 50 times 4 is going to work as well, but 50 times 4 is really 200. So I'm going to subtract out my 200, and that gives me 95. From there I need to ask, well, how many times does 4 go into 95? And that's really hard for me to figure out on my own, or the kids will say that. And so then I'll look at my 9, and I know, well, 4 times 2 gives me 8. But since this is really worth 90, I'm going to say 20 times 4 gives me 80. And I'm going to subtract that out. What I have left, I'm sorry, that should be 80. What I have left is 15. I again ask, well, how many times does 4 go into 15? And I know that 3 times 4 gets me 12. And I subtract that out one more time. Now what I have left is 3, and 4 does not go into 3, and so the kids know that that's going to be your remainder right away. Then I ask them, well, what numbers have we already used? We've already used these. We subtracted that from our dividend. I've already used my divisor, so those are out. So I'm going to add 50 plus 20 plus 3, which gets me 73 as my final quotient with a remainder of 3. There is a lot of back and forth on this, but if the more they practice, the better they will get. Another example, just picking random 3-digit numbers. Let's use 356 divided by 4. Many of the kids won't see any basic facts, so I'll ask them, well, let's circle the furthest 2 digits and say, well, 4 times what gets me close to 35? And it's not really 35, it's 350. And so I'm going to think, well, I know 4 times 7 is 28, but then 4 times 8 gets me 32. But since it's not just 35, it's 350, I want to take 80 instead of 8 times 4 equals 320. I'm going to subtract that out. And I get 36. This the kids should notice that they see a basic fact. How many times does 4 go into 36? And they'll say, well, I know that 9 times 4 equals 36. I subtract out my 36 just to make sure I don't have remainders. And then my final quotient, I've used these numbers, I've used the divisor, and so I need to add 80 plus 9, which gets me 89. One more example. Again, choosing any random numbers. I'm going to choose 572 divided by 7. Right now I don't see any basic facts that pop out, so I'm going to circle the furthest 2 digits. I'm going to say, well, I know 7 times 7 is 49, but I also know that 7 times 8 is 56, and that gets me really close. But since it's not just 57, it's really 570, I'm going to take 80 times 7, and that gets me 560, and I'm going to subtract that out. What I have left is 12, and I'm going to ask myself, well, how many times does 7 go into 12? The kids will say, well, I can't do 7 times 2, so it has to only be 1 times 7, and that gives me 7. I subtract it out, and I get 5 left. I know that 7 does not go into 5. 7 does not go into 5, and so I know that the 5 is going to be my remainder. I've used these numbers. My divisor doesn't matter, so I add up 80 plus 1, and it gets me 81 remainder 5 as my final quotient. Now the one thing you got to make sure you do is have the same digits here. That would be your divisor. Otherwise the kids might get confused on what to add together. On the next page I'm going to give you 3 different examples, and I'd like the kids to try them and bring them in. It won't be for a grade, but at least they're working on this partial quotient strategy to solve division problems. Okay, here are your 3 examples. If you wouldn't mind them trying each of them and bringing them in, we'll discuss them and keep working towards mastering partial product.